certainly with the way the bands are today, if you're not on 160, 75 meters, or sometimes 80, 40, you're not working anybody because the bands have been shot.
No, or you're on an FT8.
Well, yeah, true. Yeah, you keep bringing up FT8, the mode that David and I despise.
Same here. I'm not fond of it.
We like people that actually talk.
Right.
In any event, I'm very pleased to have Ted, KN5O. Ted and I go back way, way back, high school, you know,
Yeah.
and he's been interested in contesting and DXing since as far back as I can remember. And lately, he's been experimenting with antennas for the low bands since he's trying to work 160-meter DXCC. So, in any event, he's got some pretty good information to bring to us about low-band receiving antennas. I hope you enjoy the presentation.
Thank you, Nick. Appreciate it. And looking at the clock, it's getting late, so I'll try to go through this pretty quickly. But let me just quickly ask for the people here, how many here operate 160 meters? Barely, so that's a show of 4 hands. Okay. How many are 80-meter operators or have, spent time on 80? Okay. My focus primarily is going to be on 160, but we can apply what I'm going to talk about to 80, and probably not as critical as 160. So, how many of you all that operate either of those two bands do so primarily to do DXing? Okay, only 3. How many like just to rag chew? Okay, all right. Contesting? Yeah, okay, all right, okay. All right, well, let's get started. Well, wait a minute, this is supposed to be about the low bands. I'm sure you all have heard this. 6 meters is the magic band. And it truly is magic at times. But what is something like 160 meters? 160 meters is the mystery band. You know who coined that phrase? Me. So, what are we going to talk about today? Kind of touched on it already. A little bit of propagation. The big killer noise. Whoop, what happened to my Mickey phone? Did I knock something? Nope. Okay, there it is. All right, we're back. Yeah. Types of antennas. Ooh. I'm going to share with you my experiences. The reason I'm going to do this, because you want to know what I did and don't do it. And finally, we're going to summarize. So, as I said, we kind of queried about, your interests. And I know that's probably pretty small, so I'll read them. I was asking if you like to rag chew. Are you what I refer to a Netholic, although not so much on 160, but certainly on 80. DXer. Contester. Like me, a CW hound. Unlike me, I'm not so much a sideband or AM phone operator. Ugh. Or perhaps you're really into just listening to noise. Anyway, depending upon where you fall, that'll depend about how much you really want and how much you want to spend, how much effort you want to put forward. I need to raise this microphone. Doesn't sound like are you all hearing me okay? Okay. All right. 5 and 9, good. Okay. Anyway, that'll dictate how far you want to go with this. There's some brief stuff I put in here. When are the 160 meter and 80 meter low bands, when are they any good? Well, during the daytime, for local QSOs, pretty much any time. More so on 80 and probably less so on 160, but with you know, a lot of power and a quarter wave vertical, you can do during the day typically 300 to 500 miles. Doesn't apply to FT8. The digital stuff, obviously, with some of the stuff we saw earlier, probably can go a little further during the daytime. I don't do it, and that's why I probably don't have a whole lot of experience with it, but obviously it's being proved now since FT8's come out. For DX QSOs, pretty much the winter time at night is going to be the best time. Why? Because the D layer rises and we can get skywave propagation and the world changes on 160 from a local band to an 80 meters from a local band to a DX band. So some just general rules. Doesn't have to be in the dark for local stuff. As I said, it's kind of a repeat of what I just had. But at night, you can certainly expect with the D layer rising, you can start getting some skywave propagation, getting out to 1,000, 1,500 miles or much farther, depending upon what you have for an antenna system and power. How many here are running verticals on 80 and or 160? Okay. Anybody run dipoles on those bands? Yeah. You just want to talk stateside, that's it. And of course, ionospheric propagation can provide you not only signals, but a lot of other stuff that you don't want. For DX, you definitely need to do it at night. Although, FT8 may be proving us wrong. It could be a surprise there. More so, there are a couple of exceptions, and we'll touch on those. MUF's not an issue. We all know about the gray line and how you can get enhanced signals propagation during the gray line periods on 80 and 160. Anybody experience that? Yeah, a few of y'all have. Yeah, that's pretty typical. Basically around sunset and sun up is when you typically can kind of expect some signal enhancement. It can be quite dramatic for those of y'all that haven't operated on the bands. And again, the dark ionosphere and west, so at nighttime is the best for DXing on those bands. Okay, here's some things, and this applies to 160 and to a lesser extent on 80 meters. During the day, ground wave propagation does vary. I've seen it where you can actually make some pretty good long haul contacts during the day, and other times I can't even talk across town, more so on 160, less to extent on 80. In twilight, I've actually worked some pretty good DX right at the period I'm entering the gray line. Specifically in the last year on 80 meters, long path, listening to the southeast. I worked a station over in, I think it was Christmas Island, VK9. It was plenty loud, I was surprised. So I have a 4-square on 80, so that helps. In fact, I called Nick. In fact, I told you, I think you remember that conversation we had? Yeah. So, I mean, it's doable. As I said, I've worked both long and short paths. Speaking about the gray line, just because you are on about that time doesn't necessarily mean that any given day you're going to get signal enhancement specifically then. Sometimes signals will peak well before those times, and when you're in the gray line area, you get nothing. And there's no guarantee you can work DX on any night. And some nights you can, some nights you can't. Some nights the signals are so poor, I mean, it's like, is there something there? And other times I've seen where a guy in France is 10 over 9 on 160 meters during the middle of the night. It's incredible. I mean, I'm talking about the noise level being low, and this guy is way, way above it. Hence, the mystery. There's something called spot propagation. I don't know if any of y'all have experienced it, operated on any of those bands. It's almost like 6 meters. I can be hearing somebody, and the guy down on the Mississippi coast can't. You know, or somebody up in Alexandria is hearing something, Louisiana, Alexandria, and I can't. I mean, it's like, you see that on 6 meters a lot. And another thing you'll seem to experience more so on 160 than 80 are skew paths. You ought to be coming from the northeast, but I'm hearing him from the southeast. Huh? What gives with that? So the bottom line is, propagation, you can't do anything about it. It is what it is. And that's part of the mystery. But noise, that's the key. That's the other side of the coin to operating in these two bands. Because the old saying is, if you can't hear them, you can't work them. But we can do something about the noise, more or less. Bob's presentation with the two microphones is interesting, and we're going to touch on that here a little bit later. So the challenge is receiving. Bottom line, that's it, period. It's no surprise that the people who do well on these bands have the space for good receiving antennas. And I can imagine, you know, us having 10 or 20 acres or more. That's ideal. But a lot of us don't have that. Or you live in a location that doesn't have a lot of noise. Kind of rules out most city and urban areas, even some suburban areas. So countryside obviously is the best. Or you live on either the east or the west coast. East coast, you're closer to Europe and some sites there. On the west coast, maybe a better shot at the islands or Japan. Or frankly, if you just got to move to Florida. If you live in Florida, it seems like you can work anybody, any place, anytime. Just like these guys. And they're well-known 160-meter people. Been doing it a long time. Incredible DXCC totals from Florida. I mean, it's interesting too. 160, these guys do well. I could also tell you about guys that are on 6 meters in Florida. They do well. Go figure. Unfortunately, I haven't found any exceptions to these items up here. If you do, let me know. So, where was my low band noise likely to come from? Because I had to figure it out and solve that problem. Comes from mainly these three sources. If I'm turning my back to you, I'm sorry. I just can't read the screen from here. So I have to look up here. Mama Nature, that's one problem. We can't do too much about that. Precipitation static, thunderstorm static, you name it. Man-made noise, this is where the difficulty comes in from all sorts of sources. Things arcing, like on power lines, switching power supplies you might have at your home, modems, routers, speed controls, lighting systems, and a whole host of consumer electronics that basically just spit out a lot of noise. And then, of course, QRN, QRM from poorly designed, operated, and maintained radios from other hams. ON4UN, does everybody know John DeVolder or heard of him? He's the basic low-band guru, wrote the big book, Low-Band DXing, about that thick. Anything and everything you wanted to know about doing something on 160, 80 meters, that's the book you go to, that's the Bible. Many low-band signals aren't weak, the noise is just too damn loud. That's the bottom line. Series have ample gain. Bob Sherwood can probably attest to that. They're more, you know, and good filtering. But at the same time, they pick up a lot of noise as well. And then WAJI, anybody know Charles? Okay. He basically has stated urban, suburban, and rural environment, that plays a big part in what you can hear. It could be like as much as 30 dB or more difference between being in an urban environment for noise and being in a rural environment. I have operated at a couple of locations during contests. And I guess this was a few years ago. I was at N5YA, Bill Simpson. He lives out in East Texas on a 80-acre ranch. Rural is all get out. I mean, the only power line I see is that one power line that comes down his highway to feed power to his place. Power cable, then is buried from there all the way to his house, and then buried even more to get to the shack, which is at least a good third to half a mile away from the power line there. On 160 meters of full-size vertical, full-size, 120 plus feet. 3 elevated radials. So the top of the antenna is about 140 feet. Radial is about 20 feet off the ground. No noise. Zero, nada, zilch. I mean, the S meter on the ICOM that he had at the time, Pro 3, just sat there on the 0 pin. I've never experienced that any place, certainly not at my place. And this was at night, about midnight. I had just come from operating at the 6-meter station, and they had a contest going on at the same time on 160. So I went from the 6-meter station about 15 miles away to there. And some of the guys were operating. And who's on is HV0A, Vatican. The biggest, humongous pile you ever heard for this station. The S meter literally laid on the 0 pin. The HVA would transmit, hit at about S7. And when he quit, the USA pileup, boom, 9, 10 over. Just humongous, but I mean, just no noise. This wasn't on a special receiver. This is just on a regular old quarter-wave vertical. So location plays a big part in how well you're going to be able to hear. So what are my options to fix this? Come on. Can't control Mother Nature. I could move to a quieter location. According to my XYL, that's never going to happen. I could subscribe to a remote ham radio entity. That could solve my problem. But nah, that's not for me. If I can't do it, I'm not going to do it. Or eventually I could wind up getting some type of test equipment and try to locate these noise sources and try to fix them. And that's absolutely necessary if you can't do the second and third bullet point. Mr. Heil just gave us something. Other options are to use noise canceling. And of course, suppression technologies such as ferrites, toroids, et cetera, to reduce some common mode noise, which is also a problem. But just remember what Bob did here is a good demonstration of what can be done. And finally, you can choose to employ a better type of antenna that essentially is more directive in the way it allows you to listen to where the signal and the noise sources are coming from to see if you can get any discrimination. And as you will see, this is based on my experiences, so you don't want to do what I did, for sure. Poor planning is the first step to ruining your low-band experiences. You certainly want to avoid that. So let's see what my problem is in particular. Here's my property. And I wish I would have had a photograph of the actual, from like Google Earth, but I didn't. So just bear with me. Look at my wonderful location for the low bands. I've got a power line here. I've got a power line there. And I've got another power line going this way. I am surrounded on 3 sides by power lines. The red, you know what that is. Yeah, that's XYL forbidden territory. You cannot, will never put an antenna anywhere in that area. Period, paragraph. That's the exclusion zone, that's right. Now, as I said, poor planning. Why? Because before I ever thought of operating 160 or 80 meters, I was going to operate, when I got back on the air after being off for 30 plus years, I was just going to operate 20 through 10. And I later extended that to 40 through 10. So I grew 3 towers before I even got serious about the other one. So I got 1 tower, number 1 right there. That's the only one my wife thought I was going to put up. Then about a year later, I surprised her. I put a second one up right here. Dallas helped me, and I'm trying to think who else, but about 4 or 5 of us got together and eventually put a tower up there. And then, while my wife wasn't looking, I snuck in a third one right here. Now, to give you an idea of some distances, the house is about 100 feet across. These towers are about 150 feet apart from one another. And this 4 square, for the time being, really wasn't there. I wanted to correct the slide, and I didn't. But for the time being, imagine that's not there. Those are those 4 circles. So anyway, I had 40, I was comfy. I had 40 through 10, I was doing good. My advice is, before you do any of this, you need to think about what you want to do long term, if you can. Most of you can't, so you're going to wind up doing what I did anyway. You're going to have to figure out what you're going to do if you're going to improve it. As I said, you don't want to shoot from the hip in doing this. Otherwise, you'll be paying for that like I am and having to struggle to figure out what to do. So first things first, I wanted to find my noise sources and eliminate them when I started thinking about what I was going to do for the low bands. Because up to then I hadn't planned, but I was doing so well with my DXCC totals on 40 through 10, I was ignoring 80 and 160. And I really wanted to get my totals up there. Plus, if you want to head a contest station, if you don't have 80 or 160, I mean, that's a lot of points you're leaving on the table. So you got to do something there. So I had to get after it. I knew from earlier, just operating on 80 meters with just a plain sloper, I got a lot of pine trees on my property. I mean, these suckers are 130 feet on average. I had to use Nick's potato cannon to shoot a line up in one of them to get it up over 100 feet. That's how I put my 160 vertical up. But this, I had to have a couple of trees taken down because they were infected by pine beetles, and in the process, I had the tree removal people and put a line up for me so I could pull up a sloper. But once I did this and I got on 80, I said, darn, this is a noisy band because of my location and obviously the noise sources. So I got a spectrum analyzer and I started locating where these suckers were. My biggest problem, Chinese power supplies in your PC. Bought my PC from a local PC store down the highway. You know what they typically put in these things? Something called a Class A power supply. I didn't know what that was. Never found out about it after the fact. Sucker was radiating noise out the wazoo, especially on the low bands. Did some reading. Parker's not here. Parker Dinkins, W5ADD, said, Ted, you need to get a Class B power supply for him, which I eventually did. The guy swapped them out. Presto, my noise was gone from that. As you see, I've got power lines every place around me. One thing that they seem to do, and Katrina hit our area in 2005, so the power company, which is CLECO, Central Louisiana Electric Co-op, had gone in and replaced a lot of stuff. But since the time they replaced it in 2006, things age, things change, heating, cooling, etc. Clamps, other contacts on the poles were not as tight as they needed to be, so there was noise being generated here and there. But the biggest issue was the ones that still had lightning arresters that hadn't been replaced. And what happens is you get a lightning strike in an area, a little carbon path builds up inside the lightning arrestor, and the next thing you know, it starts generating arcs inside the arrestor. Of course, you hear them, sometimes they're off in the distance, but sometimes they're real close by because the S meter is like way over S9. Anyway, I called Coleco, begged and pleaded. They finally sent their interference guru out. They actually had one. Ham operator too, lived in our area. This was about time frame wise, 2008, 2009. Wonderful guy. He spent time with me. We went around, we located anything that was in about a half a mile of my area that was generating noise, and he wound up fixing it. He had a little spectrum analyzer in his truck, and it was wonderful. Solved all my problems. But then he had the nerve to retire. Bummer. Now I don't have anybody to call at Coleco when I have a problem that I know or can work with. They send out these guys that are just normal line people, and they don't know what they're doing. You got to try to educate them. I've got to do all the legwork. I get Nick, I get David, I get Dallas. We go out, I got Bill even. We go out and we try to locate where is this noise coming from, see if we can isolate it, and then I've got to place the call, and this lady on the other end taking the phone call says, now what do you want, what are you trying to tell me? Anyway, it's a chore now, and I hate the thought of even having to call them to get somebody out there to do something about it. My wife again. Xenon light transformer in one of the cabinets in our kitchen. She insists on putting that thing on when it doesn't need to be on. Lorraine, turn the damn thing off. And then another culprit. Plasma TV. 2008, we moved into this house. Like I said, before I even did anything on 160 or any of the other bands, even before I put up my ham antenna, I wanted a big TV. So at the time, I went out and spent $3,000 on this huge, what today is small, but to me it was a huge TV. Plasma, it was pretty. It had great pictures. It generated noise throughout the RF spectrum. From DC to light. It was like, and I kept dealing with this thing for years. And then when I wanted to get on and tell my wife, turn the damn TV off, she'd get mad, go in another room. It's like, I got to do something about this. Well, a few years ago, I decided that's the end of that TV. Because I tried filtering. I tried everything I could think of to get rid of it. The only thing that got rid of it is unplugging it and getting rid of it. Yeah.
Samsung?
No, I had a Panasonic plasma.
Do the LEDs, TVs, are they better for less noise reduction?
I hope so, because the one I got doesn't cause me any problem. So, yeah, I should have said LED. I got LCD, but it's an LED, and it's fine. It doesn't generate any noise. Thankfully, that Panasonic's still sitting in my back room. If anybody wants it, I'll be happy to make you a deal on it.
Somebody you don't like.
That's right.
Set it up to the East Coast.
Yeah, exactly. Anyway,
Somebody in Florida.
I still got a lot of other noise sources. I'm trying to eliminate them as I run across them. Wall warts. The oven in our house. I had a little analyzer I had borrowed, and as I'm going through the house with this thing, I pass by the oven. It's got a clock circuitry in it, buzzing out the wazoo. Thankfully, it doesn't seem to be radiating that far, and I don't think I'm having a problem from it. But anyway, my generator I put in the back. Right in my back. Behind, I don't have a picture up there, but I got a generator, a whole house generator sits on the back outside the bedroom. If you get too close to it, you can pick up all kinds of garbage, in the low frequency range up to about 4 megahertz. There's junk that, yeah, it's just sitting there. It's just it's a timer circuitry and all, and it just, yeah, it could be that too as well. Anyway, so I tried to do as much as I could to eliminate them, and so I got them somewhat under control. Now I started to research antennas and what I could do there. Besides, doing filtering, putting toroids and bead breakers and other things. Anyway, I was trying to minimize any chance of bringing any common mode signals in on the coax and all, so that got buried. Anyway, I was doing the prudent things I think you need to do. So I started looking around at different low-band antennas. And basically, a directive array for 160 or 80 meters is basically a way of redirecting, if you would, or eliminating or reducing the noise from different directions. So it allows you to discriminate noise from coming in from different directions. It's more or less like a beam. You can turn it and eliminate signals from different directions coming in. But in sense of like a beam forming, this really is more of a, as you turn it, you're reducing the noise in the direction that you are trying to listen. It's, if you've got a noise source, causing you grief and you want to try to minimize how much it's affecting you, you can kind of turn this thing electronically and kind of see which direction it seems to be best for listening by trying to reduce the noise floor. The various types of antennas, which you can look at in ON4UN's book or any one of a number of other books, refer to something that's called a relative directivity factor, RDF. That's kind of one of the key parameters you want to look at for selecting an antenna for the low bands. They spec it in dB, and basically it just gives you an indication of if you've got the, a flat surface, and the RF, or from an isotropic source point of view anyway, it looks like a hemisphere. And basically what this does, it gives you a measure of its ability to listen in any particular direction and discriminate noise that may be uniform from a particular region in space. So think of it as just basically having like a Yagi for the low bands. Anyway, the next page I'll show you here has got your choices and measurements of different RDF factors. Start with the first one up here, a 90-foot top-loaded transmitting vertical antenna. Gain of 1.4 dBi over isotropic, not dBd, isotropic, as a measured RDF of about 4.9. Okay, so what about all these others? K9AY, you all have heard of those. And by the way, this might vary a little bit depending upon whether it's 160, 80, and 40 meters with the RDF. K9AY, a single loop, is an RDF of 7.2. A four square of the loops, roughly 9.1. And you can go through the list. 1,000-foot beverage, 12.3. Now we're getting up there. How many of y'all got room for a 1,000-foot beverage?
North, south only.
Okay. How many of y'all have room for two 1,000-foot beverages spaced 400 feet apart? One individual. Good. I might come to where you are, Lou. Anyway, I think if you get the idea and you're looking at some of the size of distance-wise anyway, well, at least on that side, you need some room. I didn't have that kind of room. Over here now, you got things like a four square, broadside inside, high Z vertical array. That's one of these active receive arrays. Got some pretty good numbers. Inverted V, won't talk about that. But basically, on this side of the thing are antennas that are physically smaller, relatively speaking, compared to some of the ones on that side, which are larger. So space is a key consideration in your determining what you want to do, or what antenna you would like to possibly build and try out. So I'm thinking, what should I build? I said, well, I looked at I looked at the beverage. I considered that, and I figured it was the cheapest thing, and I would try that. You didn't have to spend a lot of money to build a beverage. Y'all familiar with beverage antennas? Heard of them? Basically, a matching transformer wire, a resistor, and just keep it about 3 to 6 feet off the ground, and you're in business. 160, 80, 40. 290, 585, 880, and 1160. Those are optimum lengths based on wavelengths. 5/8, 1 1/8, 1 5/8, 2 1/8. The reason that you get the eighth is that when you put them this long, ideally what that allows you to do is optimize the front to back ratio of the beverage. So that's why these numbers are up here, those particular numbers. And as you can see, roughly, they're just scaled for the next two bands. So I had a choice of what I wanted to do, and I said, well, let me see what can I do. One thing I had to consider is that the longer the beverage, the poorer the front to back, which is not necessarily a problem, but it's just a fact. The first column, as I said, the shorter ones through the long ones, but it also, I couldn't get it on the slide the way I wanted to. The antennas in this area, beverage antennas, have a beam width of about 180 degrees. In other words, if I'm listening this way, I mean I'm listening to that much. As you go longer, the beam width begins to decrease till you get to here, where you're looking at about a 50-degree beam width. So getting to the point where you might have a 4 or 5 element Yagi, so to speak, equivalent. The other thing that's not shown is that the elevation angle, so how big an area you're listening to, begins to compress as well. So the longer the beverage, the better the antenna. More exactly. But given where I live, and if you see it in the drawing I'll put up here in a minute, about 290 feet was about as much as I was going to get safely in my lot. I say safely because if I'd have done something I shouldn't have, my bride would have let me know about it. And the other problem I had is I couldn't put them on the major compass directions. I had to pick something other than those. So, again, this 4 square isn't here for the time being, so again, put that out. This is how I placed them. They were 290 feet long. This one here is 2,200. This one here is 110, 290. 295 feet. At each end, I had coax rather than try to feed. You can do beverages, you can feed them in different places depending upon how you design them. But for me, I was trying to do this simply, quickly. I just fed each one with a little transformer and some RG6 quad 75 ohm coax. So I ran 4 cables, laid them on the ground, and basically brought them back to the shack, which was kind of over in this area here. And that was it. Okay, I'm ready to go. As I said, I built 4 of them, 295 feet long. Performance, pitiful, absolutely pitiful, beyond my expectations. Totally useless on 160. 80 meters. The problem I found was that I didn't have enough gain with these. Let me go back. My focus has been primarily on DX. I need to qualify what I'm saying in that regard. They're okay for listening, stateside. Something within, when I talk about DX, let's say I'm talking 2,500 miles or greater, outside the Caribbean area, primarily, for us. These things are okay if you just wanted to listen here in the US. And maybe that's all you want to do, and in which case, that'll be fine. But that wasn't what my ultimate goal was, because I was really trying to see if I could build up my DXCC totals. The RDF of these was anywhere between 4 to 7, so to speak, depending upon 160 or 80 meters. And comparison to the RDF of just a plain vertical was 5. So I wasn't really doing much to help myself in the noise category. I used them for a while. All the while I'm doing this, I'm thinking, I got to do better. I got to do better. And of course, my initial thing was, well, I'm being a typical ham. I'm being cheap. But I realized, you know, you got to spend a few bucks if you really want to try to improve your situation from where I am, since I don't have 10 acres or 20 acres or 30 acres of property. All I had was the 2. So I begin my quest now. This has been a multi-year quest to find the best low-band receive antenna for me. So I tried the following with mixed or disappointing results. After the beverages, I saw this thing about a little small loop, 3-foot diameter loop. I knew a couple of people that were using them. I said, okay, I'm going to buy one, which I did. Installed it. Now these loops require a lot of amplification, like 50 decibels gain, because, you know, frankly, they're not much capture area. It was okay for local stuff again, but I was really, really disappointed. Plus, the RDF was lower than what I had on my beverages.
It was 4 on your list there.
Yeah. And somehow I had this old physics teacher ringing in the back of my head from high school. 'Cause you're stupid, son. Let me introduce something here. Dallas and Nick and I all went to Jesuit High School here in New Orleans. We all had the same physics teacher, even though there were 14 years difference between when Dallas graduated and Nick graduated. And I'm somewhat closer to Nick than Dallas. His name was Willie Brown. Loved the man. You couldn't help him. He was probably 65 at the time I was in high school at the time. He just had a way of making you feel really insignificant if you did something, really doing something in front of the whole class. And all I could think about as I was preparing this presentation was, what would he be doing or saying if I was telling him this?
Son, what's wrong with you?
Exactly. I continued. So the next thing I decided after that, I said I was reading about this thing called a high Z. It's one of a couple of systems that are on the market, and they got various sizes. High Z was an active receive array for 160, 80, 40. You could configure it however you wanted, made by Lee, K7TJR. Ultimately, he wound up being sued and had a partner with, I think it's DX Engineering, if I'm not mistaken. I should have looked at this before I came here. But anyway, I bought the smallest one he had, a little triangular array. It sets it up as 3 active receivers, if you would, or wideband receivers with a 20-foot aluminum antenna, spaced 50 foot apart in an equilateral triangle. I installed it in the northeast corner of my property. Remember my property, the house was kind of over here. This was kind of like in the northeast corner. It was about as far away from anything else around the house and other things that I could put it on my property. I installed it, and one of the first things you do to test it is you use it to like listen to a broadcast station up around 1600, 1700 kilohertz. And you basically can rotate the knob and you can see what happens to the signal. And sure enough, you know, I put it in and click, 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 and then the next thing you know, the signal drop. Well, from your perspective, the signal does this, you know, and as you click again, it comes back up. So it looks like it's working. And then Sure enough, I tried to listen to a station out west, and when I had it west, it was hearing him stronger. If I had it east, if it was an east station, you hear him stronger. So, okay, it's working. So it was better than the beverages for a couple of reasons. One, it took up a whole lot less space. Seemed to hear about as well as the beverages I had on my property, but I was hoping for a lot more. I was hoping it would hear better. And as it turns out, it actually did at times seem to perform better, but it still wasn't meeting my expectations. I think that was about a $500 investment. So I'm still thinking. And in one contest, I had a guy come over to operate at my station, and I was thinking at the time maybe I ought to play with a K9AY. And so he came over, and we were talking during the contest and after, and he was saying, he says, I really like your high Z. It's actually better than my K9AY. This is a fellow by the name of Mark, K5ER up in North Louisiana. So my high Z has a calculated, let me specify, these are calculated ideal conditions. It's a calculated RDF of about 9. The K9AY, only 7. That's a problem right there for me. But the other problem is because these are wideband amplifiers, and if you're in a strong RF field environment, they have a tendency to overload. So it's not really good to use these things in a multi-transmitter contest environment unless they're far, far away from your transmitting signal, which in my case, I couldn't get them far away. Anyway, I hear my physics teacher again. Don't be stupid. You don't want to do that. Okay. So going back, there's the high Z where it's located relative to the property. I continue my quest. I'd pretty much given up, but then I read an article about, I think Jack, is it Jack, W1WEF? Is that Jack? Yeah. Read an article about installing some little inductors in your beverage antenna to effectively lengthen the antenna. It slows the velocity of propagation, essentially making it a little longer. I said, oh yeah, I'll try that. That seems like that ought to maybe work. So I did. I bought some small inductors of the kind he specified. Sat there for hours inserting them. Got in that night, used it. Another disappointment. The next little while later, I tried something called a beverage on ground, basically a snake antenna. You can buy the little matching transformers. The impedance is slightly different than what you would find with a normal beverage. Normal beverage is about 450 ohms surge impedance. Beverage on ground is about between 2 and 250. So either you can wind your own transformers or buy some already made. Only problem is they're not good for our environment here in South Louisiana. They work fine if you're over rocky soil where you don't really have good conductivity. But in an area like ours where you have really good soil conductivity, they don't perform at all. I hear my physics teacher again. Love Willie Brown. So, about 2 years ago, I came across this thing called a Waller flag. It's a subset of flag antennas. You all probably have heard or read about flags, different loop configurations, triangle loop, square loop, this loop, that loop, the other loop. Doug took 2 loops and phased them. So I called him, wrote him, emailed him. Nice guy, super nice guy. And he did everything he could try to help me with, trying to talk me through this. Doug has got over 300 countries worked on 160 meters. The man must know what he's doing. He's got two big vertical loops, roughly 22 by 26, phased on a 52-foot boom. Here, let me show you. This is the drawing he sent me. You can see he's got these two loops, 22 and a half, 26 and a half, 6-foot spacing between the loops, lots of filtering, special cables to do the matching and all to keep the noise down. Anyway, the details are there. Interesting thing is Doug modeled that using EasyNet, and it's got a pretty doggone good RDF, somewhere in the neighborhood of close to 13. And in my conversations with him, he said, you know, he says, you can build a smaller version. You don't have to have one this big. Now, this thing is huge. Doug lives in a suburban lot in Florida, regular neighborhood, like many. The thing's on a 40 to 50-foot tower, maybe around 45. It's the only thing I can see from the pictures. It's the only thing apparently on his lot. He doesn't have a lot of antennas. He specializes just on 160 meters. So he's got a transmit vertical, and then he's got this. It's a big antenna. It is a frickin' big antenna. This thing probably weighs 200 pounds, maybe more. I mean, when you look at the construction of it and all that. So he put a lot of time and effort in this thing. But it's paid off for him. This is what you call a vertical Waller flag. Keep that in mind. So I figured, okay, I built 1/2 that size, so roughly scaled down to almost 1/2. Calculated on the EasyNet with this program that he gave me, RDF of 11. I'm in business now. Started construction. David came over and helped me dig my hole to put my little tower base in for row 25, because I was going to mount it about 25, 30 feet off the ground. Sitting there sweating, doing all these things. Can't imagine how much effort, time, and money I put into this. Bought all my parts that I needed from DX Engineering. Oh yeah, because when you build this antenna, it has to be done with a fiberglass frame. You can't do metal with this. This thing is strictly, basically has to be kind of isolated from any kind of coupling that could be introduced. I spent a small fortune on this thing, and it just didn't seem to work for me. And I had conversations with him, and we talked about, did you do this? Did you do that? Yes, I did this. I did that. I did this. I did that. I spent a freaking fortune on this thing. Had a handful of rotator to turn it, you know, on the top. I mean, just lots of effort, lots of time, only to find out when I compared how it was listening to my 3-element high Z array, basically no difference. In fact, the high Z was actually performing it on DX signals that I could hear at the time. I said, oh boy. I hear my physics teacher again. By the way, you're getting the picture that I was doing this haphazardly, and the answer is yeah. And I should know better. But I was getting to the point where I was so frustrated, I was trying anything and everything. Doug has a friend, JC, N4IS. Oh, by the way, they live in Florida, if I didn't mention that to you before. That should be a clue, number one. JC sells what he calls the HWF. That's the horizontal Waller flag. So instead of being like this, it's like that. The small one, and the company's name, and you can look it up on the internet, is called Top Beam. The small one's $3,000, and it goes up from there. But you got everything that you need. It needs to be at about 100 feet or higher to perform well. How many of you all have 100-foot or plus more towers? No? No? Nick does. You go to his website, and he's got the demos there. And this one that I listened to was the one on 80 meters. During the day, about 4 o'clock in the evening, his time in Florida. Turn the antenna, because it's like, imagine the Waller flag I showed you, but horizontal. So 2 loops, front and back. Turned it to where it's facing towards Europe. 80 meters during about the 4 p.m., 3:30 to 4 p.m. time frame. When on 80 meters, all you'll hear typically is just local signals and noise, band noise. And he's got a spectrum analyzer there so you can see this. He's showing you as he's tuning across the frequency down in where the DX window is. You don't really hear anything much. You hear something, but can't quite make it out. And primarily just band noise. And then he flips the switch. All of a sudden, the noise floor goes down, and you can hear these Europeans talking, and they're clear as a bell. And if you don't believe me, go to that website and watch the demo. I couldn't believe it. I must have hit something. A couple of guys that I would get on the ON4 KST chat room with actually bought this, put it up. They had the height. They're happy campers. Me, not so much. So where do I go from here? Another thing I looked at was the Array Solutions 30-foot shared apex loop. You all have heard of that, seen it, advertised, whatever? Sold by Array Solutions. Look at the RDF spec, it's only about 9, so it's not much better than the high Z as far as I was considered. But WW4LL, Fred, has one in Atlanta that I'm familiar with. Seemed to work okay for him. He was happy with it. I don't know what he's got currently, but that's what he had then. But I looked at it and I said, nope, that's not going to work for me because it basically looks like 4 triangles, at 90 degrees to each other. And so the bottom of the triangle is about that high off the ground. If it's fixed. And so for my grass cutter and all does my lawn in the back, this isn't going to work. So, But truly, if RDF is the key, then I wanted to get something with an RDF of 12 or better, but what? What is that going to be? So I thought I'd go back to what was working somewhat. High Z. But now I convinced myself I needed to get the big granddaddy of the high Z array, the 8 circle. Yep. Oh yeah, that's going to fix me up. But the question is, could I fit it on my property and make my XYL happy?
No.
You're right.
And your physics teacher said.
I spent hours looking at this thing. It required a 200-foot diameter circle optimized for 160. And about that same time, I'd given up about doing anything on 80 meters. My sole focus was on 160. Why? Because by that time, I'd put up my 80-meter foursquare. And man, I went from like 200 to nearly 300 countries like that without having any kind of special receive antenna. I mean, it was like, oh yeah. I was working stuff that I never thought I'd ever hear on 80 meters. So my 80-meter DXCC total is close to 290, which I think is pretty good considering I'd only been doing it for about really pursuing it for the last 2 or 3 years, but had been on 80 for about 7 years. Anyway, I was happy with the 80-meter foursquare, so my focus, again, going back now, is strictly on 160. The first plot I tried, which got me into trouble, was I entered the exclusion zone. Oh, no, you're not going to do that. So what was my other option? My other option was to go talk to my neighbor behind me who had some property that was just basically wooded and all. He wasn't doing anything with it. And ask him if I could have permission to put a couple of the antennas in his space, which he did. So I got the array and I installed it. So here you go. Here's my high Z. And there's the 8 circle. this is where the XYL, when I showed her that, said, yeah. Anyway, so I stole some of his land here and I put it in. And by now, some of you are sharp enough to know what I'm doing and asking yourself the question is why. Oops. Yet again, another major disappointment. Why couldn't I get it to work? My 3-element was working fine. But this just didn't seem to work at all like it should. So I called Lee and talked to him, this, that, and the other. I don't want to ruin it for you, so he told me why, and I ultimately acknowledged, but I'll tell you, I'll get to it in a minute. Like I said, I knew I was going to have problems, but I was kind of gambling in the hopes that I could prove all this theory that we're supposed to know about wrong. It's right. My physics teacher was going, "You've got to be the stupidest kid I ever taught." So here's the key. Why didn't it work? And for most of y'all, I think maybe most of y'all or some of y'all have figured it out. There's something called coupling. You shouldn't have any of these antennas. It doesn't matter what it is for 160. They shouldn't be anywhere as close to anything that looks like a tower or looks like other wire that you're using for anything. Especially at 160 meters where the wavelength is 520 some odd feet. You're in the near field of the antenna. And I really kind of knew that, but I was trying to prove it wrong. Well, guess what? No. Like I said, I ignored good engineering practice. I was limited. I didn't have the space to put this kind of antenna in that I really wanted to do. So the bottom line is, with all these receive antennas, no matter what they are, you need the room. They need to be put aside from anything else if you really want them to perform like they should. So now my physics teacher saying, "You finally got it, huh, kid?" So is there a happy ending to this story? No. Yeah, there is. Yes and no.
You divorced the wife so you could have the other property?
Interestingly enough, there was 4.5 acres next to me up for sale for a long time. This guy's pressuring me and him back there to buy it. $250,000 for 4. No way. According to my bride, we are not going to move.
The floor.
Or any place. My high Z3 element works okay. I quickly sold the 8 element, but I bought a 4 element. And I was able to position the 4 element kind of concentric with my 80 meter 4 square. My 80 meter 4 square works great. And I've got a big old tower sitting in the center of it. And the reason I did that is because the guru, ON4UN, had shown this in his book numerous times, how people built 4 squares around towers. So it obviously worked, and it does. And so I bought this, and I just positioned it just outside of the 80 meter 4 square because it's a little larger than the 4 square antenna. But then DX Engineering introduced something called a phasing controller, NCC1 at the time. I bought it. They now have an NCC2 out. WAJI says this is the best box on the market today. I then took my 3 element array and the 4 element array that I built or bought and put them into the phasing box. Wow. Wow. I began to hear stuff. Stuff that I normally had not been able to hear. According to Lee, K7TJR, he thinks I have an RDF now that approaches 12. What his 8 circle would have given me, it probably would have been better had it been an ideal situation. So phased correctly, I get about a 3 dB improvement. But 3 dB on 160 meters, believe it or not, signal-wise, is enough to be able to hear or not hear. Plus, you're not only getting the signal enhancement, but you're getting the ability to reduce the noise by essentially adjusting the phase to knock it down. So you're getting the ability to improve the signal-to-noise ratio. Unfortunately, the old problem is you almost have to adjust it for every station that you want because it's that finicky when you are trying to listen depending upon the angles that the signals are coming in from, et cetera. But if you're trying to listen to one DX station to work it, you set it up for that and you're good. Not really necessarily a great thing for contest environment, but hey. So in summarizing, propagation on 160 meters I call funky. I don't know what else to describe it. That's what it is. It's a mystery, for sure. It certainly is much more different, I think, at times than 80 meters, which I think is a little more predictable. Yeah. The one key to walk away from this is no single 160 meter receive antenna is necessarily better than any other 160 meter receive antenna. And the reason I say that is just from my experience in operating 160 meters, being on ON4 KST chat in real time, talking with other guys that are trying to work these stations, and you realize that the propagation differences sometimes mask what the performance of the antenna can be. And I've had guys saying, I can't hear him on my horizontal wall of flag at 100 feet, but I'm copying on my beverage. Or some guys saying, I've got him on my beverage, but I can't hear him on my regular beverage, but I can't hear him on my beverage on ground. Or I've got that. Trust me when I say in the 3 to 4 years I've been doing this pretty actively, there is no single one best antenna at any particular point in time. It's that much of a difference. In fact, I've actually heard stations sometimes better on my quarter wave vertical than I've actually had them on any of the other antennas. And if you think 160 meter propagation is strange, who worked FT8ZM on when they were at Armstrong? What's the name of the island? Amsterdam. If you know where Amsterdam is, that's literally the antipode to where we are here in South Louisiana by about 600 miles. So it's about as far away from us as we could get.
Plus it was skewed too.
It was skewed, and K9CT has produced a video. He did it a few years ago, and it's a real runtime video of 160 meter propagation as they're working into the United States. And you can just see it favors this area, might favor this area, and favors this area as the days and nights go forward. What's up with that? So what's clear is that certain latitudes or location, though, typically do seem to have better 160 meter propagation. Or if you live in Florida, you're in business. It's been a struggle for me, I'll admit. I've got 190 DXCCs worked, 185 confirmed on 160 meters. And I continue my effort. Son, you finally passed the test. Any questions?
On your 160, did you put them in the same orientation, or you staggered? Like, here's your 4 for 80 and 160s?
I set them up such that each one is for north pointing. They tell you, to make sure that you're on them, to have the major compass directions. Yeah. So they did one for one, one for the other. They're about a quarter wavelength apart on 160. Basically, I feed them with the RG59 coax, all you need to do, and then the phasing box has got the ability to adjust the phasing and amplitude and all that so that you can optimize your reception on any one particular signal. Yeah. Yeah.
Did you have to put radials down for those?
No, there's no radials, and I'm glad you brought that up. That's another thing on these receive antennas. Having a radial field beneath them is not a good thing. So wherever you put them, make sure you don't have a radial field. At least not the ones, these active receive arrays. No, bad thing. Bad. Don't do that. Yeah.
You're using your inverted L for the transmit?
Transmit.
And then those 7, was it 7?
I use the 3 element and now a 4 element.
So 7?
Yeah, well, I got two arrays that are listening to the same, that are listening to the same station or pointing to the same station, and then I try to phase it such that I can increase their signal effectively by 3 dB and reduce the noise by trying to cancel the noise at the same time with them.
I assume on your 3 towers, your HF, the higher bands, the Yagis or something.
That's right.
So I assume the tower by your house is noisier than the 2 out there in the field. That's what I.
Yeah, if I had an antenna that was on the same band as the other ones, yes, it's a little bit noisier. But as I said earlier, I went through trying to eliminate a lot of that noise. It was bugging me on 160 and 80, but it also bugged me on the other bands as well. So yes, that's another thing. I didn't. Sorry, I hit that. I should have, again, poor planning, getting back into ham radio after being off for 32 years. I forgot a lot of stuff, and I didn't read up as much or talk to anybody. I just went back into it and made a lot of mistakes. One of the mistakes was putting that tower close to the house for the noise reason, for the XYL reason as well.
In my case, I've got 4 towers that are 200 to 350 feet from the house, and 2 towers that are near the house in the garage. Major difference.
Absolutely. The farther away you can locate your antennas, you can make up the loss in coax by just buying bigger coax, frankly. The farther away you get it from all this consumer electronics garbage and power lines and anything else that causes you grief, the better off you're going to be. You want to lower that noise floor.
What spectrum analyzer and other devices you use to try to find the local noise source?
Yeah, I borrowed an Anritsu spectrum analyzer from Parker W5ADD. It's about a $6,000-$7,000 box. But he had it. He bought it because he was having problems, and he was kind enough to loan it to me. So that's what I use. But other things you can do that are almost far similar is just use your regular ham radio, drive around in a car, and with some short antennas, you can spot a lot of this stuff just by locating. One thing that's interesting for you guys that are running into noise sources, I found that most of the noise sources that are created by the public utilities that really bother me are generally within a half a mile. Beyond that, they may be noisy, but for most HF, let's say 40 and up, 40 meters and up, they really won't bother you. Now, when you get down low, 80, 160, those noise sources could be a mile, 2, 3 miles away. And what they do basically is they radiate that noise over the power lines. The power lines act like big antennas because of the length and at that frequency. So you may be getting noise that you hear on 160 and 80, you don't hear on 40. And the reason for that is that those signals attenuate a lot more on the higher up in frequency you go, but the lower frequencies, they travel a lot farther. So there you get to be a little more of a problem because as you expand that search for where your noise sources are, you're obviously magnifying the search area. Yeah. Any other questions? Well, thank you all. I appreciate it.